Hello. Hi. Hi, everybody. It is day 27 of studying math in every day. And today is another beautiful day. It's another wonderful day, although it is late. But yeah, it's fine. I can do 2 sessions and I can nail them. Who knows? So yesterday was just like Friday and I wasn't studying. Like I was kind of maybe studying, but I didn't study it. It's just like I was reviewing stuff. It's reviewing also studying. I don't know, but like yeah, I did one session and it was just like it was a review.
rewrite the
Like
question.
I was reviewing a bunch of like I was reviewing like the stuff that I have learned before.
Retrieval.
Like I didn't study something new. So today is the day. It is the day for doing that. It is the day for doing that. It is the day for literally doing that. Okay. So. कर रही है तेरी मोहब्बत जिंदगी I want to get the Gmail. Yo, what up? Okay, what up? What up, man? What up, man? It's like, don't redeem me. So. Isn't again. What? 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 I already logged in one tab, and the other one is asking me like, that's weird. To be honest, what? No way. This is eating my time, dude. Like eating my time. Is this the one? Like the new one? It's taking. Supposed to get listening, but don't remember. Of course. Ugh. Uniform motion problems? Should I just say that? Like cinema? I don't even know. I never heard of it. Like am I cooked? Guys, am I cooked? Like, I never heard of the title. Like it is saying uniform motion problems. Never heard of them. Like literally never heard of them. But yeah, it's just like it's like yes, looks scary. Oh, Is this like some type of what is called like physics? Like I remember like the distance stuff back in school. Rate and time. I think I can have remember. So like, but that was physics though. I don't know if this is kind of like the same, but like yeah, let's see. Very but is in this game. Okay, the music was already playing. I didn't know that. It was already playing. Let's do it. Yo chat, let's do it. Let's do it together maybe. Okay. I don't even have a chat. Why I'm saying yo chat? Like I don't. Okay, yeah, fake it till you make it. Use that. Like fake it till you make it. So let's stop it up and do it. Play the timer. No, a few. Play this one too. What the heck? Is it already late? Like probably somewhere 10:45 a.m. Way too late. Okay, so in this lesson we will look at how to compare and solve for values of the variable in the distance. In this lesson we will look at how to compare and solve for values of the variables in the distance equation. Okay, it is distance rate times time. Okay, so d equals to rt. Okay, when we have a case of uniform motion, is the music big? Okay, when we have a case of uniform motion and a pair of related scenarios, including a pair of scenarios with the same distance but different speeds and times, didn't get the whole point. I literally didn't get the whole point. Okay, when we have a case of uniform motion and a pair of related scenarios include what is a uniform motion first of all? Like you didn't mention it anywhere. I don't know what uniform motion is. Should I just use AI? Because like What? What is the rate basically? What? What? You know, like, there is something that I forgot. Like, I believe I can use this for asking more questions.
Now, in this
And I can also look for a lesson. What is called? Isn't like I didn't know she had a YouTube channel. Swear to God, this is the exact same girl that is teaching my discourse. What? Maybe you can watch this one of her videos. Oh, even she's posting recently. Didn't know that. Does she have like free courses right here? Calculus 2. Oh, I didn't know that. I didn't know this at all. Like, really, I didn't know this at all. Okay. Okay, it is what it is, man. So, just click this. Go back. Remove that. Why is this loading like that long? What? Oh, it's a uniform motion. I think this takes a little bit, takes some time. Oh, okay. Oh, surname. Catherine or something. I forgot it. Vista.
In this video, we're going to be doing a uniform motion problem, and we call these types of problems uniform motion problems because the two objects that are moving, or the two people that are moving, move in the same way, and most commonly this means that they travel the same distance. In this video, we're going to be doing a uniform motion problem, and we call these types of problems uniform motion problems because the two objects that are moving, or the two people that are moving, move in the same way, and most commonly this means that they travel the same distance. So in this particular problem, we're told that Arnold and Kay make the same trip, but they do it on different days. So for example, Arnold makes the trip on Tuesday, Kay makes the In this video, we're going to be doing a uniform motion problem, and we call these types of problems uniform motion problems because the two objects that are moving, or the two people that are moving, move in the same way, and most commonly this means that they travel the same distance. So in this particular problem, we're told that
And also
Arnold
the
and
same
Kay
speed, isn't
make
it?
the same trip, but they do it on different days. So for example, Arnold makes the trip on Tuesday, Kay makes the trip on Thursday. The reason that they tell you they're making the same trip is to let you know that they travel the same amount of distance. So Arnold traveled at 12 miles an hour, Kay traveled at 20 miles an hour, so the trip took her 2 hours less than it took Arnold, which makes sense because if Kay traveled at a faster speed, then the trip is going to take her less time. How far did they travel? So what was the distance that they traveled? Well, to solve a uniform motion problem, the first thing we want to remember is that we're going to be using this equation here for distance, which tells us that distance is equal to rate times time. So if I multiply together the rate that I travel and the amount of time I travel, then I'm going to get the amount of distance that I travel. So this is going to be the formula that we're going to use. The first thing we want to do then is draw a diagram of our motion. So we're going to say both Arnold and Kay started at the same point. So we're going to say that they started here and that they traveled to this point here. So we'll go ahead and say that Arnold started here and he traveled to this point, and so we can call this Arnold's distance. So we'll say the distance of Arnold, d sub a, and then we'll say that Kay started at the same point. She made the same trip, so she started at the same point, she traveled to the same point, and so this is going to be Kay's distance, or d sub k. Because they made the same trip and we know that they traveled the same distance, we can go ahead and say that d sub a, Arnold's distance, is going to be equal to d sub k, Kay's distance. Now we know that distance is equal to rate times time. So when you look at this formula, what we want to realize is that we can make a substitution, right? We know that d is equal to RT, so we can use these interchangeably. So instead of saying distance, we can say rate times time. So we can say Arnold's rate, R sub A, times Arnold's time, T sub A, is going to be equal to K's rate times K's time. So K's rate times K's time. We just substituted rate times time for distance. Since we know that their distances are equal, we know that the product of their rates and times are also going to be equal. The reason we wanted to get to this point is because the only information we've been given in this problem is about Arnold and Kay's rate and time. We haven't been given any information about their distance. That's the unknown that we need to find. So we wanted to get the equation in this form so that we could start plugging in some of the values we've been given. So let's write down what we know, what we've been told in the problem. It says Arnold traveled at a rate of 12 miles an hour. So that's going to be Arnold's rate. So we can go ahead and say Arnold's rate, or R sub A, is going to be equal to 12. We've been told Kay traveled at 20 miles per hour. So that's going to be Kay's rate. So we can say Kay's rate, or R sub K, is going to be equal to 20. Then it tells us the trip took Kay 2 hours less than it took Arnold because she traveled faster. So we can say that K's time, or T sub K, K's time, is going to be equal to Arnold's time, so T sub A, minus 2. And that should make sense to us because if we think about this, if we say, let's just pretend for a second, that the trip took Arnold 10 hours, then we can say T sub A is 10, we get 10 minus 2, and we can say K's time is 8. So if Arnold's time were 10, then K's time would be 8, and that would make sense because we know that it took K 2 hours less than it took Arnold, and 8 is 2 less than 10. So we know we've written an accurate equation here that relates K's time to Arnold's time. So now with these three pieces of information, we can go ahead and plug into this rate times time equation here. We know R sub A is equal to 12, so we'll go ahead and plug that in. We don't have a value yet for T sub A, so we'll go ahead and leave that as is. We know R sub K is equal to 20, K's rate is 20, and we know T sub K, K's time, is equal to T sub A minus 2, so T sub A minus 2. Now we want to go ahead and simplify and solve for T sub A, which is the only variable we have remaining. So we'll get 12 times T sub A is equal to 20 times T sub A minus 40. We just distributed this 20 across the T sub A and then negative 2. Now if we subtract 20 T sub A
Okay, I think I'm getting it now. I'm getting it now. I think I'm okay now. Okay. 3 hours later, so it will be 7, 8, 9, 9:30. They didn't mention that nowhere. At the time. Is it 10:30? Isn't it 9:30? Nah, yes, it is 10:30. Yeah, right. Okay, you were slow, dude. They both are slow. Okay, let me know. What is the average like? What is the average of a person? What is the average speed of a person walking? Okay. It is 4.8 kilometers per hour. Dude, like 4. Ah, okay. Okay. Let's just try this one. These guys, they were saying, we cannot take it anymore. The local storage is full. You solved a lot of problems in here. So many your own business or like pay the subscription. That's what they were saying. So I'm gonna save this to my desk. I'm gonna delete the whole thing. So now let's do this. Nah. So if you wanna I don't totally like this, man. Okay, what I can do is this. That I couldn't. What? Okay. How can I call Bjorn? I cannot write the whole thing. And also I cannot use an image. Yeah, I can give to this. What? Dude, what the heck's going on? Like, what? Why is he hallucinating? Like, why? It's telling me to sign in, man. I don't even know me. I'm gonna use another AI. What? This looks like OC. Okay, they're asking me about the speed. But like the actual formula was this: D times T and what? T times. No, it's just rate times T. Okay, so the second iterant. What about the first iterant? Should I name it like T1? It looks like I'm gonna call it TR1, and then it's just this. What I have is the time, 8 hours, and the second iterant, which is TR2, equals to time equals to 10 hours, and also hours. And what else? Rate. The rate. It's also okay, body miles per hour. Okay. What about the distance though? Okay, this terrain is distance, so the distance would be always the same, you know? So I can find the distance using like the terrain tool is the terrain tool is time and rate. So I can get the distance equals to T, which is rate, which is 40 times body, not 40, but okay, the rate is 40 and the time is 10. Still like 400 or something? No way. Okay, the distance is 400 miles per hour. Nah, just like miles. That's all you need. So the terrain. Okay, we're gonna look for the speed, the rate, basically. Okay, so equals to R and T. So in this case, the distance, which is 400 miles, equals to the rate. We don't know the rate, but like we know the speed. Basically, now we know the time, which is 8 hours. We don't know the rate, and then we know the time, which is 8 hours. Basically, 8 hours. So we need to divide R on both sides. So that's what we need. Now first we need to multiply, which is like we need to isolate R. So we're gonna divide both sides by 8 hours and also 8 hours. So they will cancel. And then this. So now it is 400 divided by 8. Let me use some calculator basically. 400 divided by 8, 50 kilometers per hour. Now 50, what is 50 miles per hour? Don't I need to do that? Okay, 40 miles per hour. Yeah, that's how I need to do it. Miles per hour. Like this, am I right? Am I right? I don't know. Mama. So let's see. Terrain 1. Terrain 2. Okay, terrain 1. Now look at the hours. Terrain 2. We got this, so we can find the distance based on like the terrain 2 is information. Because like they were traveling to the distance was the same. Okay, so this one, and terrain 2 is 400 miles. The terrain 2 traveled the same distance, so we can equate the value we just found for D2. Okay, this is 50 miles per hour. Okay, so I'm right. Okay, so I did it right. Now, feel me. my gosh. I broke the rest, I swear to God. I broke the rest of my chair, man. I literally broke it again. Yeah, I broke it before and I broke it again. Damn, why did I cry? My chair is broken. It's fine. Oh. Nobody near the seat, I believe. Yeah. So we don't need another. We don't need a break time today. So we are about to just start the second session, the next session basically. So let's start it. So it is going to be, let's do problem number 2. What isn't taking me? That's fine. Okay, so let's okay, I started this one. I started this one yet. So let's maybe try another problem. The problem alone is just like 3 paragraphs, by the way. It's 2 paragraphs, yeah. So okay, Cassie is driving at a constant rate of 30 miles per hour on the highway. 4 hours later, her friend Susan starts from the same point and drives at constant rate of 60 miles per hour and passes Cassie. Okay, how many hours had each woman been traveling at a time that Susan passed Cassie? Wait up. شرابك هاي سوق هذا هايده يا So Cassie is driving at a constant rate of 30 miles per hour, and she's from the US. I'm talking about the teacher, Krista. That's why she's using miles, and we don't use that, man. Here's the metric system. I think they call it metric system, what we use, kilometer and stuff. Metric system. It's a metric system. Okay. Is this like, I don't know. Right. This is not what I'm looking for. But yeah. So Cassie is driving at a constant rate of 30 miles per hour on the highway. 4 hours later, Her friend Susan starts from the same point and drives at a constant rate of 60 miles per hour and passes Casey. How many hours had each woman been traveling at the time that Susan passed Casey? And how far had each woman traveled at that time? What? Since each woman is traveling at a uniform rate, we could it is uniform. Okay, we recognize this is a uniform motion problem, so we can use the equation d equals to rt, where d is the distance each of them traveled, r is the rate at which they traveled, and t is the time it took them to get the place where Susan passed Casey. What? We can use subscripts. Dude, why is this sounds like too much? Maybe I need to break it down like in I need to break the example down. Alright, that's what I need. So Cassie is driving at a constant rate of 30 miles per hour on a highway. Okay, 4 hours later, her friend Susan starts from the same point and drives at a constant rate of 60 miles per hour and passes Casey. How many hours had each woman been traveling at the time that Susan passed? And how far had each woman traveled at that time? They are talking about like at the time that, what was the name of the girl? Okay. Yes, at the time that Susan passes Casey. That's the time we're looking for. That's the time we are looking for. So how many hours had each woman been? Okay, and how far each woman traveled at that time? Since each woman is traveling at a uniform rate, we recognize this is a uniform motion problem, so we can use the equation d equals to rt, where d is the distance each of them traveled. Okay, each of them traveled. So we can use the equation d equals r t, where d is the distance of each of them traveled, r is the rate at which they traveled, and t is the time it took them to get to the place where Susan passed Casey. I would like to be on a coffee today. I'm way too sleepy, I don't know. And I get like enough sleep last night, but I don't know. Okay, we can use subscripts to set up a unique equation for each woman's travel. Okay, 60 miles. Okay, so I got the distance, which is like, no, I didn't get the distance, but like I got the, what is called, the time, not the time, but like the rate of, like, you know, Susan, and also we got the, like, you know, the time, which is 4 hours. So even like it took, yeah, but we got that, we basically got that. Okay, so 4 hours later, her friend Susan starts from this. How many hours each woman had been traveling at the time that Susan passed, and how far? Okay, where up then? Okay. I'm way sleepy, man. I don't know. So yeah, I have to reason, you know. I have to think. I'm gonna take a picture of it and then go back to the AI and then say, give me this in a plain text, text. I see. Why cannot write in a beautiful way? And let's be honest, guys. I think it is not good me writing all of this on a withdrawal and on the computer. Like, it is not totally good. Like, you know, what I used to do was just like to go back on my, like, you know, my notebook, like the notebook that I write my problems. So I used like I used to go back to it and I just like see and watch and also just like maybe review the way that I solved some of the previous problems that I have solved. So now it will be kind of hard, like, you know, to check and to look back at the old problems that I have solved. It's gonna get like some of them, they will be lost even. I won't be able. So yeah, here's what it is. It's just like I'm kinda showing my thoughts, you know, and make reasoning. Okay, so we got like rate of what? 30 miles per hour. And also 4 hours later, her friend Susan starts from the same point and she waves at a constant of. Okay, we don't know the time, to be honest, and we don't know the distance. Okay, what about Susan? What about Susan's time? What about Susan? Yes. The rate is 60 miles per hour. So what is that? And the time that it took her is 4 hours basically. So what is the distance that she traveled? We need to find like Susan's distance. So this time, this 4 hours, I think is the 4 hours that it took Susan to reach where Cassie was at that time, at the time that she was passing Cassie, right? So these are the time that like it took is to Susan just to reach and pass Casey. So I think like in general, if it took Susan to travel like, you know, where Casey was just in 4 hours and the rate was 60 like miles per hour, for sure it took Casey like the double, because like, you know, Susan was traveling the double speed of like Cassie, right? She was traveling 60 miles per hour while Cassie is traveling like to 30 miles per hour. So it is the double, and that means it's gonna take double of the hours, like double of the time basically. So it will be 8 hours in general. So let's see if our what is called let's see if okay, so let's see if the formula that we will use gives us the exact same thing, if it will give us 8. So first let's find the distance based on like Susan's information. So the distance will be, it's just like the rate times the time, d equals to 60 miles per hour, and then the time, which is like 4. So it will be 120 and 120. It's just how many? Like I don't know. It's like 120 and 120. It's 100. It's just like 220, 20 and 40. It's 240 like miles, I believe. It's just like d equals to 400 miles. So based on this, we got this one, which is like 400 miles, right? So let's plug this 400 miles right here. So let's see if it is the same thing. So d equals to rate times time. We got the distance, which is like 400 miles, time is r, which is 30, and what t, the time, which we don't know yet. So we're gonna divide both sides of the equation by 30. So let's see. So 400 divided by 30. What? Time? You don't know the time yet, right? Well, 400 divided by 30. Still like 13 something blah blah blah, which is silly. Nope. Am I doing something wrong? Let me go back to this. What made it like it is 240, dude? It's not 400. What the heck? Yes, I'm right. 60 times 4, which is like 240. Why the how did I bought this 400? Like even I said 240, I even said it. Oh my gosh, holy shit. 240. And also this should be also the same. It is 240. So 240 divided by 30, which is 8. Okay, it is the exact same thing that I was saying. So this is 8. Like this is, I don't know how to deal with the unit store. Oh, I don't know it, to be honest. So it will be just 8 hours, by the way. this will be 8 and this one will cancel, so it's 8 hours. Time is just 8 hours. 8 hours. So it's the exact same thing that I was saying, right? It's gonna take double the time. I broke my chair. I'm crying. Okay. What else? The D, which is like just 240. Oh. Okay, so let's read it. Okay, since each woman is traveling at a uniform rate, we recognize this is a uniform motion problem. How are they traveling like a uniform rate? You know, this is a uniform motion, but like uniform rate isn't like, shouldn't it be like uniform rate? Shouldn't it be like the same rate, the same speed? Since each woman is traveling at a uniform rate. Okay, one is traveling 30 miles per hour and one is traveling like 60 miles per hour. How are they uniform? Like, there is something wrong with my, like, okay. Okay, yeah, okay, it makes sense then. Okay, we recognize this is as uniform motion problem, so we can use the equation D equals to RT, where D is the distance each of them traveled. R is the rate at which they traveled, and T is the time it took them to get to the place where Susan passed Casey. Okay, we can use subscripts to set up a unique equation for each. I didn't do that, but yeah, it's just like keeping this other. What? They totally use it another technique. What the heck? Yes, I totally take another bet. Okay, 1/2. Which is so funny. What? This is so damn good. But like, this may be confusing somebody, but like, I swear to God, like this way is a lot cleaner. I think it is a lot understandable. My way basically is a lot understandable, because like the fact that they traveled the exact same distance, you can get the distance, right? Just using this info, like Susanne's info, 60 miles per hour, and the time that it took her, right? And also, once you get the distance is the same, right? Once you get that, you can just like plug it in right here, and you can get the time that it took Cassie to reach at that point, at that distance, to travel maybe that distance, and like what speed that she was traveling. So yeah. So another problem. Do you guys have another problem? Nope, they don't. So maybe I can cover this. A quiz, I mean, you know, you feel me? Where is this? Okay, so after I finish this section, there will be only 3 sessions left, but like they are way too long, to be honest. Look, take a look at this one. It's like an hour. It's just like 2 hours. 2 hours maybe. It's just like way too much, man. Like that is 2 hours and 3 hours, like 3 hours of content are left. Ooh, and I will be ending. I will be finishing Algebra 2. Maybe like I can do it in this month. I don't know. June. And then I have to prepare like the exams in July. And then I have to take the exam. Like I'm talking about, I'm gonna take 2 exams at the same time. The one from Algebra 1 and the one from Algebra 2 at the same time. Right? So maybe I have to do that. Yeah, maybe it sounds like reasonable, so yeah, I will. So let's stop yapping and let's do this. On Monday, Jenny blah 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 blah. Okay. Dude, this is so long. It's just way too long. Should I just like, okay, copy image, and then what? This one says on Monday, Jenny walked at 3 miles per hour from the school to the library. Okay, walked at 3 miles per hour from the school to the library. On Tuesday, she was slow. Okay, on Tuesday, Kelly walked at 6 miles per hour from the school to the library, and it took her 1 hour to get there. How long did it take Jenny to get from the school to the library? Okay, so Kelly walked at 6 miles per hour from the school to the library. Okay, do Jenny and Kelly live in the same from the school and from the school to the library? So yeah, okay, it's just the same distance. So this is just so simple, dude, that I don't even have to think. Let's forget about should I try to use the exact same thing that she was trying to use in this problem, just this, the time that I took Casey and the time that I took Suzanne. Is this should I, or should I just do the normal one, not a shortcut? Don't have yeah, okay, let me just use the normal one. Gonna use, okay, so this one is just J, okay, which is Jenny. Maybe just you can write it Jenny. So Jenny took you a lot of time, to be honest. Okay, so now, okay, sorry, let me do it for Kaylee first. Kaylee, and then Kaylee, time is 1 hour and an hour. Okay, to get there, 1 hour. Okay, rate, which is 6 miles per hour. And what? And the distance, question mark. So distance equals to rate and time. So distance equals to what? 6? What? Is it just gonna be rate and okay, 6 miles? Damn. Okay, what about the other side? The time, we don't know the time. Basically, we don't know the time. We know the rate is 3, and then what about the distance, which is 6 miles? Okay, miles per hour. So D equals to R and time. So in this case, I got 6 miles equals to what? R, which is the rate, which is 3, M, 3 miles. Okay, times what? We don't know the time. 3 miles per hour. We don't know the time. So need to divide both sides by 3, which is 6 miles. But miles per hour, I think you have to also deal with the miles per hour. So this will cancel. And what about this? You all need to divide this. So should be 2 miles per hour. 2 miles per hour. So it's just so simple. It's 2 miles per hour. This one kind of a little bit difficult. Jenny and Ken made the same trip on different days. Okay, when Janet made the trip, she traveled at 25 miles per hour. Right. Okay. She traveled at 25 miles per hour. When Ken made the trip, he traveled at 35 miles per hour, and the trip took him 4 hours, less than it took Janet. Wait. This one is a little bit trickier, maybe. I'm talking about this problem. So, okay. Not like there's no way that I can find. Oh my gosh. What's a little bit sound stuff? Sound sad. Should I give up already? Should I give up already? Like, should I? Nah. Do it. One can make the trip. He traveled 35 miles. So less than. Because, like, we don't already know the time that it took Janet, right? Janet. Rate of 25 miles per hour. And what? Nobody knows the time. Okay. And also nobody knows the distance. Okay, what about this? Oh, Janet. Okay. So what about Ken? Keen. Okay. One Keen made the trip. The rate's already there, okay? No. $35 miles per hour. Okay. And the trip took him like 4 less hours, you know? We don't know the time at this case too. Okay. 4 less hours less than DJ, which is Janet. The distance is just like unknown. Dude, how should I approach like a problem like this? Let me think. Like I'm missing 2 variables, you know? I'm missing 2 variables. That's where the problem rises. You know? Feel me. I'm missing 2 variables, right? What? I'm gonna give up on this. I'm about to give it a shot tomorrow. Yeah, I'm gonna give a shot to this problem tomorrow. So I will take my shot, because like 100% of the takes that you don't take, of the shots that you don't take, it's just like you miss it. 100% shots that you don't take, you miss it, dude. So I'm gonna take a shot tomorrow of it, basically of this problem, and then I will see if I get it right or not. And if I don't, I will just like take a look at the solution, so it doesn't make sense. It will be something new that I'm learning, because like I didn't work it on something like this right before. So yeah, the whole thing is just like, you know, yeah, you're gonna know it. So no worries, man. Oh, by the way, I'm gonna call this session, I'm gonna call it a day right here. So till we're gonna see tomorrow again. See you guys. It was another amazing day, and I'm already in day 27. Day 27. I'm so close to a month, like without even like breaking the chain, without even like losing, or like without even missing a day. Like this, I'm doing like consistently. Consistency is the key. Talking to my mom. So, see you all